So this is the part of the presentation where we kind of get into the nitty-gritty of things just a bit. So the reason I gave you the setup for the actual situation and then the cancer situation was to talk a little more about statistics. So if you want to write some things down, the book has this as well. This is going to be a little tricky but important. The way I want to start this actually off is I want to go back to the example we used on the very first week of class. Remember we talked about this idea of 30 days of above 100 degrees or 1 day of above 100 degrees. So let's go back to that example. So let's say, do you remember what we were trying to decide there? Let's say it was the 30 straight days of above 100 degrees, if you want to write that down. 30 straight days in Roanoke of above 100 degrees. What was the question that I wanted to figure out there? Is that
statistically significant?
Yeah, is that result due to chance, or is there some other variable that could be causing it, such as climate? That was the question. So if you want to write the question again, if you had 30 straight days of above 100 degrees, is that result due to chance, or is that result due to something else, like climate change? Right? That's the question, right? So we figured out, or I told you, I think, that the probability that that could happen due to chance, and if you want to even write this down, the probability that that could happen due to chance might be 1 in 100. Let's just say 1 in 100. Probably even less than that, but let's just say 1 in 100. So a computer could figure out, yeah, the probability of this happening due to chance is 1 out of 100. If that is indeed the case, what decision do you make statistically?
It is statistically significant.
You would make the decision that that is unlikely due to chance, it is significant, and you would say, you know what? That could only happen due to chance 1 out of 100 times.
Right, we said that.
That is so unlikely, I'm going to say it is not due to chance. So 30 straight days, you're going to say that result was not due to chance. That result was due to a factor, a variable, such as climate change. Is that clear for everybody?
Mm-hmm.
Beverly, is that good for you?
Yep.
So the question is, what if it turns out that that result really happened just due to chance?
But that...
It's very unlikely that that did happen due to chance, but what if it did? What if that result really was just... Now, what if it really did happen due to chance, and you made the decision this was statistically significant, but it really was just a chance event?
We made an error.
You would have made an error. You would have said, this is significant, but it really wasn't. That situation where you said your decision, so the top line will say no significance. Now I didn't do that one quite right. The bottom will say significant. And you made a decision that this result, you collected data and it was statistically significant, so you said, oh, this was due to an independent variable, but in reality, actually for actual situation, write no effect. Right? No effect, where it says actual situation. No effect. And then in actual situation for significance, write effect, that there was an effect. So you made a decision. You collected your data. It was statistically significant. And you said, aha, this result is statistically significant. There is climate change. But what if that result happened due to chance? That would be called a error, and it would be a false alarm. It's called a false alarm. You said something was significant, but it was just due to chance. That's called a false alarm. The other name for that is called a type 1 error. You said something is significant, but it just happened due to random chance.
So does that not go under the significant?
Well, your decision... Oh, you're right. I screwed it up.
Okay.
Thank you. Sorry. Just screwing up with the notes here, Beverly. Yeah, you're right.
Okay.
You said you found data. It's like the cancer situation. You said, hey, this is statistically significant. And you said, this is due to climate change. But it really just was a fluke. 1 out of 100.
Right.
So that would be a false alarm.
Okay.
It's also called, as you look in your book, a type 1 error. Hang in there, Em. Part 2. Let's say that you collected data and it was statistically significant, the climate change, and you said, this is statistically significant, and it turns out it was due to climate change. What would that be called?
Then that would be a correct decision?
Yeah, that would be called a hit. That would be called a hit. You said, based on the statistics, hey, I collected this data, and this data said, this is statistically significant. This isn't due to chance. This is due to some other variable, such as the climate. And it turns out, in reality, there is climate change. So that would be a hit. That's a good thing. We like, when we collect data and it says statistically significant, we like hits. Third situation. Let's say you collect data, and the data is non-significant. It's below the critical value. So it's let's say there were 5 days this month above 100 degrees. 5 days. And let's say it was 5 days and you said, you know what, that could happen due to chance 20% of the time. So you collected that data, you said, this is not significant, this is just due random fluctuation. If it really was no climate change, would that be a correct decision?
Correct no decision.
That would be a correct no decision. I collected data, it said non-significant, and in reality, there was no climate change. That would,
Pardon all my...
hang in there. We're almost done. If you need to excuse yourself, you can.
No, you're fine.
It's okay. A correct no decision that would be. Don't worry, we're on the last one here. The final situation. You collect data. So let's say it's that 5 again. 5 days in a month. And you say, you know what, that could happen due to chance, 5 or 20% of the time. I'm going to say there's no climate change here. But what happens if in reality there really was climate change and you just didn't get the data?
And this would be error miss.
A miss. A type 2 error or miss. You missed an effect. You collected data. It was not significant. So you said, no, there's no effect. But in reality, you just missed the effect. You missed it. That would be a type 2 error. I know you're kind of just following along here, right? Are you understanding, Em?
I'm understanding.
Okay. Beverly, is this good for you? Okay. The final thing that I'm going to bring in to our situation here is I want to actually go, for the final thing, you want to have some good notes on this, back to this second ANOVA, the one with the .07. The review example. Do you guys remember that .07? What was that, Alexis? What was the term used to describe a .07?
Marginally significant.
Marginally significant. Close to being significant. But if we had to make a binary decision, Beverly, what would be our decision if it was .07 and it was binary? Would we say significant or would we say non-significant?
Well, it's non-significant, but wouldn't we report it as marginally significant?
You would, kind of maybe, but if it was a binary decision and it was either significant or not, you'd actually have to say no. So if you had to make a decision, just a yes, no, you'd have to say, this is not significant. So that would have to be your binary decision. Why would we not want to say that, though? What would be the problem with saying that? If we said it wasn't significant, what error might we be making there?
Because Because it's close to significant?
It's close to significant, so if we say no effect, we could be making a miss. If we have to make a decision on a .07, we might say, oh, there's no effect here. But we're really close. We might be missing an effect. There could be a type 2 error. We don't want that to happen. So, go ahead.
I thought it was statistically significant.
Well, it was, in this case, we're saying it is not statistically significant. .07 is not quite. If it's .05, less than significant, greater than .05, no. We'd have to say,
yeah, this is less than a...
no, .07 is greater than that.
Right.
It's okay. So it's close, but if we had to make a binary decision, we'd have to say no. We'd have to say there's no effect here, but we would be very cautious in doing that because we'd be very nervous that we might have a miss here.
Which is a type 2 error.
A type 2 error. We'd be very worried about a type 2 error here. The way we would fix this, there is a way to fix this. How many people do we have in this study, in that example?
6.
6 people. Is that a lot of people?
No.
6 people is nothing. 6 people is nothing. And so what we would say we would want to do is we'd want to increase our sample size. So what we would say, and if you want to write this down, we would want to increase our sample size. The reason we'd want to increase our sample size is because we want something, and the book talks about this, we want more power. We want more power. And hopefully in the book, hopefully it talks about power. It's not on those pages. Power, let me tell you what power is. Power is the ability to have hits. Power is the ability to have hits, to have something is significant and it really did have an impact. When you do studies, you want a lot of power. You really want to say significant difference, and in reality, it really did work. If you only have 6 people, you have very little power. The way to fix the power problem and prevent these type 2 errors is you increase your sample size, and you may want to just write this down and know it. Increasing sample size increases your power, and if you simply add people, you're going to have more power. And if you add 6 more people to this, the .07 is probably going to turn into a significant effect. Alexis, does that work for you?
Yes, sir.
Beverly, is that working for you?
Mm-hmm.
Emily? Okay. So that'll conclude this part of the presentation.